So we talked about what is information visualization. You might ask that why do we need so? We have the data, we have tools like mean, median, standard deviation, Pearson's correlation coefficient, and so on and so forth, all the numerical tools. Why do we need information visualization? Is it because it's cool or it's colorful or something like this? Well, the goal of data visualization is gaining insight into the data. So it is important to remember this. The goal is understanding, is gaining insight into the data, in other words, understanding. How? By examining each variable in isolation, studying the relation between variables, and so on, so forth. And we will talk about this how very soon. But the goal is gaining insight into data. The reason that we use data visualization is, well, it is very efficient to see patterns and anti-patterns, which means irregularities of data using information visualization. It's more efficient. Comparing to what? Comparing to numerical tools. Or comparing to looking at the values, looking at the data. It's very efficient to summarize for huge volumes of values. Okay? So you have a data set of, let's say, number of rows 500,000, and if you want to go through one variable, you will have 500,000 digits to study one by one. It's impractical. You might say that, okay, I'm using mean, median, standard deviation. Yes, that's very helpful. But sometimes it is very difficult to see the patterns and irregularities even using the numerical tools. And this is the third reason. It is very effective to reveal hidden irregularities. So some of the irregularities, some of the patterns are hidden. They don't reveal themselves very easily unless you use information visualization or more sophisticated numerical tools. In many cases, data visualization is more efficient than numerical exploration. Okay? So more efficient and more effective to reveal concealed patterns than numerical exploration. However, numerical tools and the visual tools are not competing. They are supplementary. They're completing each other. We use both of them. It is efficient and effective, the information visualization, with a very big if. If it is used properly, using best practices. So not all visualizations, not all plots are identical or equivalent in terms of effectiveness and efficiency. Okay? Some plots are very difficult to understand. Some of them are easier. So when we talk about information visualization is revealing some patterns and irregularities, we are talking about proper information visualizations using the best practices. And in this session, for some simple situations, I'll introduce you to some very good practices and best practices. There are a few other points about why information visualization, and I like them, so I have added them here. There are two quotes. One of them, again, from Ware et al. Through vision, we gain more information than through all other senses together. And a considerable part of human brain is dedicated to analysis of visual information. So our brain is very capable, naturally capable, to understand visual patterns. And we want to use it. We want to put it in practice to analyze data. Sukup and Davidson say that human brain is wired for pattern finding, and in fact, it is the most sophisticated pattern recognition machine. So we want to use this very sophisticated and capable pattern recognition machine in our work. Let's benefit from it. So these are all the answers to why do we use information visualization. Because it's efficient, because it's effective, and it's a very, very good supplementary to numerical tools. Because our brain is wired to recognize visual patterns way better than understanding numbers. In an example, this is a data set of 53,000, 54,000, let me change the color, 54,000 records and 10 fields or variables. And it's about diamonds. It's a very famous data set. Every record is a diamond. It says that the first record, it's a diamond with carat 0.23. Cut is ideal. Color is E, anything that it is. Clarity is SI2. Depth is 61.5. Table is 55. Price is 326. And then we have X, Y, Z, the dimensions of the diamond. So it's a good practice now to stop this video and write down the types of these variables. Then play this video again. I will show you what are the types. Okay, this data set is a cross-sectional data set. Let's start from this point, because it's a snapshot in the life of these subjects, these diamonds. It's not how the cut changes over time, or how the carat changes over time, or how the price evolves over time. It's just one snapshot of the life cycle, of the life of the presence of these diamonds. What about the variables? Carat is numerical. So I put an N here. Let me change the color. What about the cut? The cut seems categorical to me because there are a few repeating values like ideal, and then premium and good, premium, good, very good, very good, very good, fair, very good, good, ideal. You can see that they are being repeated. And it seems that this variable tends to lump up, to group all our items, all our diamonds into fewer groups that are ideal, premium, good, very good, and fair. So 50,000, 54,000 diamonds into 5 groups. So this one is categorical. What about color? Color has the same story. A few repeating values in order to group the whole records into fewer similar groups. So this one is categorical as well. What about clarity? Same. It is categorical. What about depth? So to me, it's a numerical. It's a numerical variable, and indeed it is continuous. It is not discrete. What about table? It is numerical and continuous. What about the price? So let me move these diamonds here. These are diamonds. What about the price? It is numerical and continuous. About X, Y, Z, to me all seem numerical and continuous. So let's say that we want to study the price. We want to study this variable. How many numbers do we have in this variable? Well, equal to the number of records, 54,000 almost. So one way is going through all that 54,000 numbers. The other way is using numerical ways to approach it, numerical tools like calculating mean and then median and then standard deviation, okay, and then minimum and then maximum, and based on these two, range, and any other thing that you might want to calculate using numerical tools. But we can have everything almost in one plot. If we visualize properly this variable, we would have a histogram. What this histogram is telling us? It's telling us that there are a very few diamonds here with very high prices. This is price, and this is count. So histogram is, we will see it very soon, is putting the variable price into these brackets. Okay, so for instance, this is 0 to 500 might be. This one is 500 to 1000. These are my guesses. I'm not sure, but I'm showing you the process. And then it counts how many diamonds are in the bracket of 0 to 500. And we can see around 200, I don't know, maybe 2000, sorry. And here around 13,000. And so on and so forth. So what we can see, the first thing that I can see is there are a few diamonds with very high prices, $18,000 to $19,000. However, most of the diamonds are located around here, between $0 to $3,000. So this is the range of price that I saw. I figured out that there are a few very expensive diamonds, but most of diamonds are in this range. I see that the most frequent price category is something around 500 to 1000, which is another thing to know. I figured that there are some diamonds with very, very low price, which is quite interesting. Before that, I thought that I used to think that diamonds are very, very expensive, but it seems that we can buy something even with our small pockets. And what else? So I can guess about mean and median of this plot, but I rather use numerical tools than my guess. So instead of studying 50,000 or something, 54,000 diamonds, I had a glance at its distribution, the price distribution, and I got many interesting points. So this is why information visualization is so efficient. In a very short time, I got insights into this variable. Let's go and talk about how to do information visualization.